China is moving ahead in its quest for space exploration. China is now looking at other solar systems after sending robots to the moon, landing them on Mars, and building its own space station. Scientists will reveal comprehensive plans for the country's first expedition to detect exoplanets later this month. What are exoplanets and do they exist? How do we know they aren't already inhabited if they do? All will be answered. Just stick till the end of the video. Hello and welcome to Tipsy Alien, where we discuss the most mind-blowing facts about aliens, extraterrestrial life, and space exploration. Subscribe to our channel and press the bell icon so you don't miss future updates. Without further ado, let's get straight into this. If a petition by the Shanghai Astronomical Observatory is approved this summer, China might soon undertake its first space-based search for exoplanets. The Earth 2.0 telescope would spend 4 years circling the Sun-Earth Lagrange point 2 at a distance of 930,000 miles, 1.5 million kilometers. It would point its 7 telescopes toward the galactic center and look for evidence of dimming when planets transited or passed in front of stars as they orbited. The project will study planets outside the solar system and other areas of the Milky Way in the hopes of discovering the first Earth-like planet orbiting the habitable zone of a star similar to the Sun. Astronomers believe that such a planet, dubbed Earth 2.0, would have the ideal circumstances for liquid water and life. More than 5,000 exoplanets have previously been identified in the Milky Way, mostly using NASA's Kepler telescope, which was operational for 9 years before running out of fuel in 2018. Some planets were rocky Earth-like bodies around tiny red dwarf stars, but none were Earth 2.0. According to Jesse Christensen, an astrophysicist at the NASA Exoplanet Science Institute at the California Institute of Technology in Pasadena, finding the signal of a small Earth-like planet with current technology and telescopes is extremely difficult when their host stars are 1 million times heavier and 1 billion times brighter. The Chinese Earth 2.0 initiative intends to fix that. It's being supported by the Chinese Academy of Sciences and is in the early stages of development. If an expert panel approves the designs in June, the mission team will obtain money to build the satellite. The spacecraft will be launched on a Long March rocket before the end of 2026, according to the crew. The Earth 2.0 spacecraft will carry 7 telescopes to monitor the sky for 4 years. 6 telescopes will collaborate to examine the Cygnus Lyra constellations, the same sky area as the Kepler telescope surveyed. The Kepler area is low-hanging fruit since we have extremely good data from there, says Jian Ji, the astronomer coordinating the Earth 2.0 project at the Chinese Academy of Sciences Shanghai Astronomical Observatory. The telescopes will seek exoplanets by detecting slight fluctuations in the brightness of a star that signal a planet has passed in front of it. Using numerous tiny telescopes together provides scientists with a broader field of vision than a single huge telescope like Kepler. Earth 2.0's 6 telescopes will look at around 1.2 million stars across a 500 square degree piece of sky, which is almost 5 times broader than Kepler's vision. Simultaneously, Earth 2.0 can study fainter and more distant stars than NASA's Transiting Exoplanet Survey satellite, TESS, which studies brilliant stars close to Earth. In terms of sky surveying capability, our spacecraft might be 10 to 15 times more powerful than NASA's Kepler telescope, G adds. The 7th sensor aboard the spacecraft will be a gravitational microlensing telescope for observing rogue planets, free-roaming celestial objects that do not orbit any star, and exoplanets like Neptune that are distant from their star. It detects variations in starlight when the gravity of a planet or star warps the light of a background star in front of which it is traveling. The telescope will be aimed at the center of the Milky Way, which contains a tremendous number of stars. According to G, if the launch is successful, this will be the first gravitational microlensing telescope to operate from orbit. Our spacecraft can essentially undertake a census of exoplanets of various sizes, masses, and ages. The mission will acquire a large number of exoplanet samples for future investigation, he explains. NASA launched Kepler in 2009 with the goal of determining how frequently Earth-like planets are in the galaxy. Astronomers must measure the time it takes an exoplanet to orbit its solar to prove if it is Earth-like. Such planets should have comparable orbital periods to Earth and transit their suns yearly. According to Chelsea Huang, An astronomer at the University of Southern Queensland in Toowoomba, scientists require at least 3 transits to calculate an exact orbital period, which takes roughly 3 years of data, and perhaps longer if data gaps exist. However, 4 years into the Kepler mission, equipment elements broke, preventing the telescope from staring at a single patch of sky for a lengthy period of time. According to Huang, who has served as a data simulation consultant with the Earth 2.0 team, Kepler was on the verge of discovering several Earth-like planets. Astronomers may have another 4 years of data with Earth 2.0, which, when paired with Kepler's findings, may assist in confirming which exoplanets are actually Earth-like. I'm extremely thrilled about the potential of returning to the Kepler area, Christensen says, adding that he expects to analyze Earth 2.0 data if it becomes available. G is hoping to discover a dozen Earth 2.0 worlds. He expects to disseminate the data within a year or 2 of its collecting. There will be a lot of data, he adds, so we'll need all the hands we can get. The project now comprises approximately 300 scientists and engineers, most Chinese, but G hopes that additional astronomers from across the world will join. Earth 2.0 provides a chance for improved international cooperation. The European Space Agency also proposes an exoplanet mission named Planetary Transits and Oscillation of Stars, PLATO, for 2026. PLATO's design includes 26 telescopes, giving it a broader field of vision than Earth 2.0. However, the satellite's focus will vary every 2 years to monitor various portions of the sky. Funding decisions are due in June. If the Earth 2.0 telescope mission is chosen, the crew will begin preparing the satellite for launch in 2026. Another extraterrestrial proposal is in the running, which tries to locate exoplanets by measuring how a star wobbles around the system's center of mass due to the planet's gravity impact. China has just lately begun building its space science missions. However, other fields of space activities such as human spaceflight, lunar exploration, and remote sensing and communications have flourished for many years. The Wukong Dark Matter Probe, the Hard X-ray Modulation Telescope, and the Mosey Quantum Research Satellite were among the first space science missions launched by China between 2015 and 2017. A collection of planets discovered by NASA's Kepler spacecraft includes one with many similarities with Earth. Kepler 452b circles its star at a roughly comparable distance, while its radius is 60% greater. According to mission experts, it is the most Earth-like planet ever discovered. Astronomers are interested in such worlds because they may be tiny and chilly enough to have liquid water on their surface, hence be friendly to life. NASA's scientific head John Grunsfeld dubbed the new world Earth 2.0 and said it was the closest so far to Earth. It is around 1,400 light-years from Earth. According to John Jenkins, the Kepler data processing head at NASA Ames Research Center in California, it gives me great pleasure to bring you this news today. A new youngster on the block has recently moved in next door. The new world joins other exoplanets like Kepler 186f, which are comparable to Earth in many respects. Which is the most Earth-like is determined by the attributes considered. Kepler 186f, discovered in 2014, is smaller than the new planet, but circles a red dwarf star far colder than our Sun. Kepler 452b, on the other hand, orbits a parent star that belongs to the same class as the Sun. It is just 4% more massive and 10% brighter. Kepler 452b's orbital period is 5% longer than Earth's, taking 385 days to complete a full circle of its star. Because the mass of Kepler 452b cannot yet be determined, astronomers must depend on models to predict a range of probable masses, the most likely of which is 5 times that of Earth. If it is rocky, active volcanism is expected, and its gravity might be nearly double that of our planet. After decades of study, scientists are sure that one day Earth will be impossible to live on, and we have to find another planet that has all these features that our Earth has. Scientists are hopeful that one day humans will step onto a new planet and call it home. Please put your comments in the comment section below, and don't forget to share. Thanks for watching.